Folk, welcome to your last couple days of math class of the school year. Today we're looking at Appendix C, which is on the fundamental counting principle, which is actually pretty interesting. You've probably thought of these scenarios before. Okay, so there's just one objective. It is using the fundamental counting principle to determine the number of possible outcomes in a given situation. So here we go. Here's a situation that requires the fundamental counting principle. Let's suppose you're selecting your clothes that you're going to wear today, because you might be in your PJs still. You are choosing between 2 pairs of jeans and 3 shirts. Here is a tree diagram that depicts the situation. So that's you. You can either pick the blue jeans or the dark jeans. And you can, with the blue jeans, you could do the white shirt, the yellow shirt, or the blue shirt. Or with the dark jeans, you could do the white shirt, the yellow shirt, and the blue shirt. So how many possibilities do you have with 2 jeans and 3 shirts? You've got 6 possibilities. That leads us to the fundamental counting principle. It says if you have 2 jeans and 3 shirts and 6 shoes, that to figure out the combination of possible outfits you could wear, you multiply the numbers together. Simple stuff. So the fundamental counting principle, you've probably thought about this before. You multiply the number of options and you get your total number of possible whatevers you're talking about. So here's the scenario. A restaurant offers 6 appetizers and 14 main courses. And how many ways can a person order a 2-course meal? So this is interesting. You wouldn't know this if you were just looking at a menu, but now you can think about it next time you go order some food. So to figure out how many ways you could order different meals, it would be 6 times 14. There are 84 possibilities. The possibilities are not endless, right? There's an end to the possibilities. There's 84 possibilities. Yikes. Might have spelled that wrong. I don't know. It doesn't matter. Hey, look, Jimbo's here. Next year, Jimbo is planning on taking 3 courses in college, math, English, and humanities. Based on time blocks and highly recommended professors, there are 8 sections of math, 5 sections of English, and 4 sections of humanities that Jimbo finds suitable. Assuming there are no scheduling conflicts, how many different 3-course schedules are possible? So a lot of words to find those 3 numbers. You got 8 math, 5 English, 4 humanities. Multiply those out, and there's 160 possibilities. That's correct. Up there, I don't know what I was thinking. Hey, Tesla, that's for you, Drew, is experimenting with lightweight 3-wheel cars designed for one person and considered ideal for city driving. If you'd like one, you have some choices to make. There are 9 paint colors to choose, with or without air conditioning, electric or gas-powered. Uh-oh, Tesla, what are you doing? Gas-powered. With or without an onboard computer, and with or without a GPS. And how many ways can this car be ordered in regards to the options? So, clearly we have 9 paint choices. Now it could be with or without air conditioning. So how many options is that? That's 2. Electric or gas, again, 2. With or without a computer, 2. With or without a GPS, 2. So how many ways could we order this car? 9 times 2 times 2 times 2 times 2 times 2. So 2 times 2 times 2 times 2, that would be 16. 9 times 16, there's 144 different ways. Oh, here you go. You're taking a multiple choice test question that has 10 questions. Each of the questions has 4 answer choices with 1 correct per question. If you select one of these 4 choices for each question and leave nothing blank, and how many different ways could you answer those questions? So you have 4 choices on the first one. You have 4 choices on the second one. You have 4 choices on and so on and so forth. How many choices of them do you have? You have 10 of them. 4 to the 10th.
No.
Pull out the calculator for that one because that one's big. What? Why is my calculator not working? Oh my goodness. My batteries get dislodged. It was just working like 3 minutes ago. How silly is this? Let's see if it works now. There we go. Okay. So what was it? 4 to the 10th. 4 to the 10th. Oh, wow. Look at that. That's just 10 That's just a 10 question multiple choice test. Think about how long some of those other tests are. On just a 10 question test, there are 1,048,576 different ways that you could fill out that test. That is incredible. Think about that for a second. I have one more scenario for you on the back. It's about telephone numbers. Also interesting to think about. Telephone numbers in the U.S. begin with a 3-digit area code followed by 7-digit local telephone numbers. Area codes and local telephone numbers cannot begin with 1 or 0. How many different telephone numbers are possible? Okay, so we'll have to kind of draw this one out. 1, 2, 3, area code, 1, 2, 3, 1, 2, 3, 4. Right, that's how phones work. Okay. Now, they gave us some stipulations. Area codes cannot begin with 0 or 1. So this can't be a 0 or 1. So how many choices are left? There's 2, 3, 4, 5, 6, 7, 8, and 9. So how many numbers is that? 8 choices here. Now this one can be 0 through 9. So there are 10 choices there. This one can be 0 through 9, and there are 10 choices there. It also says local telephone numbers cannot begin with 0 or 1. So once again, you have 8 choices here for the same reason you had 8 choices there. And the rest of the numbers can be any of the 10 numbers that you have 0 through 9. So the fundamental counting principle says we can multiply all of that out. I see 8 times 8, which is 64, and then times all of those 10s, there are 1, 2, 3, 4, 5, 6, 7, 8 10s, so that would be 8 zeros. So with our current phone number, what do you say? I don't know, specifications, the way that you can do our phone numbers right now, there are 6,400,000,000 combinations of phone numbers. So that's quite a bit. We could almost do the whole world, but that's just the U.S. And, there's like, 400 million people in the U.S. So we still have 6 billion phone numbers out there that we can probably use. Probably more, maybe less, I don't know. Not everybody has a phone, right? All right, so there you go, fundamental counting principles. Kind of interesting stuff to look at. So have fun with that. Talk to you soon. Have a great, 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 great day.